Well, thank you. Thanks, Flavio, for the introduction. So hello, everyone. So this is Jingqing Zhang. So it's my great pleasure today to introduce our recent work at the Imperial College Data Science Institute on the deep learning, especially using background knowledge to achieve high accurate sequence learning on traffic and natural language area. So actually, we are living in a world that is full of sequential data such as text, video, stock, weather, and etc. So in many cases, we humans may understand the world by learning a sequence of behaviors, no matter consciously or unconsciously. So therefore, the sequence learning is believed to be a fundamental human ability, but it can be difficult for computers. The sequence itself can be very informative. So early research has explored temporal patterns of sequence, such as autoregression, moving average, support vector regression, and Gaussian process. So even nowadays, many forecasting products and also decision strategies are still using such temporal patterns as strong indicators. So however, the information of the sequence itself is usually not enough. So in practical scenarios, the background knowledge can be very important. So therefore, in our recent work, we try to take the advantage of background information to achieve better accuracy on practical tasks. So the first work I will introduce today is about the traffic prediction with auxiliary information. So in this project, we quantify and use the impact of online search query to predict traffic speed. And the second project is still in progress, and we try to use knowledge graphs to achieve zero-shot task classification. And finally, I will introduce TensorLayer, which is a deep learning tool developed by our group, and we also plan to integrate it with HPC systems to combine the advantages of both platforms. So here's the first quick poll question. So would you use Google Map or other map app to search the destination you will go before departure? So yes or no? Personally, I use Google Maps a lot, especially when I go somewhere I'm not really familiar with or go to attend some events. So if thousands of people or even more use map app to navigate, the number of search queries can be a very strong indicator to predict heavy traffic. In our recent traffic prediction project, so our motivations are straightforward. So the first one is the limited access to the traffic data. So most current available traffic data sets are small scale or focused on highway or long auxiliary information. So I will show you a comparison table which between the data sets we propose and other data sets in a later slide. And the second motivation is that we believe that both online and offline information can indicate and predict the traffic condition. More particularly, the search queries on map app or the road network and also like the holidays, such public events. And the figure on the right-hand side shows the correlation between number of search queries and the traffic speed in a related area. So the left sub-figure shows the average traffic speed, and the right sub-figure shows the query number. The blue lines are the normal conditions, and the red lines are unusual conditions. So as you can see, that the dramatic increase of query number can lead to a dramatic decrease of traffic speed. So our recent work has been this work has been accepted by the KD 2018. We released a large-scale traffic data set. We call it Q traffic because query traffic. We call it Q traffic, and we also proposed a hybrid deep learning model to combine offline attributes, spatial dependencies, online search queries for traffic prediction. The Q traffic dataset collects traffic data in Beijing, and the data is provided by Baidu Map. The last figure shows the distribution of road segments that we collected in Beijing, and the right table compares the Q traffic with other popular traffic datasets. So as you can see that the Q traffic is much larger than all previous datasets. So the first column, the Q traffic has much larger scale. And the Q traffic also provides more domains of information, including road information, road network, and also the online query number. And we also collect data from both highway and urban area. And now it is available to download. So one of the main contributions of our work is to use search query to improve traffic prediction. It is assumed that query can help to predict traffic in a region affected by the public event, because the quick boost of search query is usually caused by the public events, such as concerts, forums, place of interest, anniversaries, and etc. So because of the public events, the traffic can be unusually heavier, and such conditions cannot be captured by pure temporal model, but can be indicated by the number of search queries. So we propose an algorithm to discover the event by query record. There are two concepts that we define. The first concept is called moment, which is basically given a location, so the timestamp that the number of search query is dramatically higher than usual conditions. So if this time the query is much more than normal condition, then we call this time moment. And the second concept is event, which is defined as the time period during which the timestamps are all moments. So note that the timestamp here I mentioned is the estimated arrival time of each search query instead of the searching time. So the moment and event we just defined can probably show the exact time of a public event. We have demonstrated that there is a clear correlation between query count and the traffic speed in the previous slide. Therefore, we propose an algorithm to measure the influence of query on road segments, which we call it query impact. It is calculated based on the query count and the distance between the destination of the queries and the neighboring locations. So the more query, the higher query impact, and also higher impact if the place is closer to the destination that people are searching. So here is a demonstration of our hybrid deep learning model, so which combines auxiliary information from 3 domains. The base model is the sequence-to-sequence model. So given a sequence of previous traffic speed, the model predicts the traffic speed in the near future. And then we use a graph CNN to encode spatial dependencies within a local road network. And secondly, we use a wide deep module to encode the attribute into the model. The attribute includes the public holidays, whether it is holiday or not, the road class, the speed limit, the number of lines, and etc. So, and thirdly, we also most importantly, we encode the query impact into the model with an RNN. So the results show that the error rate is lower if the query impact is applied. So the last 2 rows are the models with query impact, and you can see that the query impact is really helpful, and the hybrid model is the best. And the improvement during event is higher than the whole data set, because as we say that we think the search queries can help to predict, especially during the event, which is usually the traffic that is very heavy. So in addition to our traffic project, we are also trying to apply the deep sequence learning with the background knowledge to the task classification. So second poll question. So if you are given the sentence, this removes bulky error, such as mechanism and sulfate, as well as bacteria and other large partials. So this sentence comes from the economics. So which category do you think does this sentence belong to? So science or business or partial? Or person. So I think this is a very straightforward or simple question for humans. So I believe all of you can easily identify it is a scientific expression. More specifically, it talks about chemistry. So we believe the reason why human can specify the category easily, even without any training sample, is the keywords, such as the iron, the sulfate, and the partials. So these keywords are actually very closely related to chemistry and science. So in practical scenario, the traditional assumption of closed world classification that the classes in testing set must be seen during training cannot adapt to the dynamic open world. So insufficient training data of real and emerging classes is also a big challenge of many classification tasks. So therefore, the zero-shot learning or nearly zero-shot learning can be necessary. So formally, the problem can be defined as we have two sets of classes. One is seen, and the other is unseen. So during training, only the task from seen classes can be used. The TI refers to the task, and the YI refers to the class. And the YI belongs to the set of seen classes only during training. And during testing, the format of data is exactly the same as the training set. But except the classes of tasks can be either seen or unseen. As we believe the background knowledge can help machine to better understand natural language, so we use ConceptNet, which is a knowledge graph of general human knowledge, to achieve zero-shot test classification. So we propose a framework which has two phrases. So the first phrase, which is called the confidence prediction, predicts the confidence that TI belongs to each class. So in this phrase, we use a CN-based single classifier together with a relation vector extracted from the ConceptNet. The relation vector are calculated based on the distance between the class label and each word in the ConceptNet. So the closer the word connected with the class label, the relation vector, the value in the relation vector will be higher. And the second phrase is called two-step classification. So based on the confidence predicted in the first phrase, the second phrase will finally specify a class. If the confidence that the task belongs to any class is higher than the threshold 0.5, we'll call it the task is accepted by the class. So if the task is accepted by any seen class, the class has the highest confidence will be the final prediction. So however, if the task is rejected by all the seen classes, so then we have to find unseen class that the task may belong to. So in order to transfer the knowledge from the knowledge we learned from the seen to the unseen classes, so we define a score function based on the class hierarchy. The unseen classes that has the highest score function will be selected as the final prediction. So we have applied our framework onto the DBpedia ontology dataset. So 75% of the classes are seen and 25% are unseen. The classes are selected randomly for 10 times, and the results here in the table are the average result. As you can see, the knowledge graph can significantly help the framework to classify instances of unseen classes correctly. So without the relation vector, which so the first three columns of this table, you can see the accuracy of classifying unseen classes is 2.3, but with the relationship vector from the concept net, which are the middle three columns and the right three columns, the accuracy increases to around 40%. And the second phrase, the two-step classification, slightly undermines the accuracy of classifying seen classes, but double the accuracy on unseen classes and results in a better accuracy overall. So the first row in this table is without the two-step classification, and the second row and the third row are using the two-step classification. So at the same time, the score function we define using the class hierarchy can also improve the accuracy of unseen and the overall results, but not really significantly. So this project is still in progress. We plan to test our framework on more data sets and make it more general and robust. Imperial Data Science Institute also released a deep learning development tool, which is called TensorLayer. So it is a high-level wrapper of TensorFlow, naturally supports low-level APIs of TensorFlow. So nowadays, the deep learning has enabled many AI systems to exhibit unprecedented performance even beyond humans. Besides dataset, algorithm, and hardware, the efficient development tools are also essential for the success of deep learning. The TensorLayer is designed to make the deep neural network development as easy as possible. So most of our current deep learning researches are implemented by TensorLayer, and TensorLayer is open source on GitHub. The integration of TensorLayer with HPCC system is also what we plan to do in the near future. So in the future, we plan to carry on our test mining research. So the classification is just the beginning. So primary results have shown that the background knowledge, especially the structured knowledge, can help machine to understand natural language better. And we believe the summarization of a scientific document or a collection of scientific documents is a more complicated and useful task that can be, and it can be a real challenge in the near future. And we also plan to integrate the TensorLayer with HPCC system. The HPCC system provides outstanding computational capability, which can be useful for parallel training of neural networks to find the best parameters and hyperparameters. And HPCC also provides efficient data delivery system. And meanwhile, the TensorLayer is an easy-to-use deep learning tool. So therefore, the integration of TensorLayer with HPCC system should combine the advantages from both. That's it. So thank you very much.
Sorry, I was on mute there. Thank you so much. This is a fantastic presentation. So, Jingqing, I'm going to give you a moment to go and look at the questions. And while you do that, I'm going to review the answers to your poll questions. So your first poll question is, would you use Google Maps or any other map app to search the destination you will go before departure? And so 100% have said yes, and we do have an international audience on here today, so it sounds like around the world that's something that people do, and that's good to know. And your second poll question was a little bit of a pop quiz for us. So the question was, and this is from The Economist, it says, what category does the following paragraph belong to? This removes bulky ions, such as magnesium and sulfate, as well as bacteria and other large particles. So of our voters, unanimously, it was science. But if we look into the questions from the audience, somebody put something in here. So if we, let's see, it could be business involving science. So it says if we remove icons or ions, the article source economist may be business involving science. So what do you think of that, Jingqing?
Oh, yeah, I think that's right. So the context is always very important to decide the class or understand the semantic inside the sentence. Yes, so without considering more context, only focus on this sentence only, we may think that it talks about science only. But if consider the whole article, so it may talk about the science with business. So it can be a multi-label classification rather than a single label classification. So that is what we are also trying to achieve in the future. So we think that single label classification is not enough for our task. So we should consider the combination of multi-class. Yeah.
So you're making us think this morning. That's fantastic. All right. If you're ready, we'll go ahead and move on to our first question, which is, why do you use the two-phrase framework to classify text?
Yes. So well, our framework has two phrases. The first phrase is confidence prediction, which is trained by label data with thin classes only. The second phrase specifies a thin class or unseen class. So why the second phrase is necessary? Because we find that the trained model is more reliable on thin classes than unseen classes during testing, which makes sense because our model is trained on thin classes only. So it is more reliable on thin classes. So therefore, we apply the second phrase to transfer the knowledge learned from the thin to unseen, so based on the class hierarchy, so that the prediction on unseen classes can be more accurate. Yeah.
All right, thank you. All right, it looks like we have one more question from the audience. So anyone else out there, if you have a question, go ahead and enter it now. So starting with our last question, is how many events are discovered based on the search queries?
So the data we collected is between April 1st, 2017 to the May 31st, 2017. So it's basically 2 months. And during the 2 months, in Beijing, we discovered 932 events in Beijing. So some popular places include the National Gym, Shangri-La restaurants, and some universities, etc. So you may find more details in our KD paper. We list some examples we have found from the search query.
All right, fantastic. All right, it looks like that's our last question. So thank you very much for presenting today, Jingqing. We're just thrilled that you could be here with us. And your presentation is very good and very interesting, so thank you.